5x to the third power, all squared, times 2x to the seventh power. And so to simplify that, I think I'll start with if our base is a product rule, and so we need to apply this exponent to both factors of the base. So that means I would have to square 5, and I would have to square x to the third power, okay, because this is a product, and so we apply that exponent to each factor of the base. And then I still have to multiply by 2x to the seventh, eventually. Okay? And so the next rule is, well, we can just clean up 5 squared, 25. And then our next rule is going to be the power rule. So we have x to the third power squared. That was x to the sixth, because you're going to multiply those exponents. And then I'm still going to have to multiply by 2x to the seventh. I think I'll just use a dot to show the multiplication now, rather than the parentheses, but either one would be fine. And now at this point, I can use the commutative and associative properties. So basically what I want to do is simplify plain old numbers, multiply them together, and multiply together anything exponential with the same base. So I'm sort of in my mind thinking that I need to commute the factors and associate them together. So I'm going to be doing 25 times 2, and then I'm going to be doing x to the 6th times x to the 7th. So plain old numbers just get multiplied, and exponential expressions with the same base of x, we will then, since we're multiplying, it's the product rule, we're going to add those exponents. So our final result is going to be 50x to the 13th. Okay, we're going to use the rules of exponents again to simplify this expression. And so I look at this and I think, okay, the first thing that I want to do is use the power rule, because I have a lot of pieces here that have an exponential expression raised to another power. So I'm going to first apply the power rule, which says that if we have an exponential expression to a power, we are going to multiply those exponents together. So this will give me x to the 10th right here. And over here I have a negative exponent in there, but that's okay. The rules apply whether your exponents are positive or negative. And so I still want to multiply these exponents together. And so I'm going to be multiplying x to the negative 12 in the numerator. And then in my denominator, I'm going to use the power rule down here also. So x squared to the third power is x to the 6th, and I multiply those exponents together. And next I'm going to, I think I'll clean up my numerator now, because remember in the order of operations, a fraction bar is like a grouping symbol. So it kind of says clean up the numerator and the denominator if you can. So I can probably think of doing this next. And now I'm multiplying exponential expressions with the same base. So I'm going to keep that base and I'm going to add the exponents. Even though one's negative, I need to add those exponents. So I'm thinking to myself, x to the 10 plus a negative 12, or just 10 minus 12 in the numerator there, and dividing by x to the 6th still. So that cleans up to x to the negative 2 over x to the 6th in the numerator, applying our, what we called earlier, the product rule. When you multiply exponential expressions with the same base, you want to add those exponents. Okay, so now finally I can use my quotient rule, because now I have a division problem, same base, okay, but I'm trying to divide these exponential expressions. So the rule says that I keep the base, but I subtract the exponents. So be careful here, because you always want to start with the exponent in the numerator and subtract the exponent in the denominator. So I would be thinking x to the negative 2 minus 6 power, numerator exponent minus denominator exponent. And so when I take negative 2 and subtract 6 from it, that gives me negative 8. So I have x to the negative 8th. And so I'm kind of running out of room here, but the final thing we probably do is apply the definition. Most of the time to simplify means don't leave it with negative exponents. And so the final step would be apply the definition. What does x to the negative 8th mean? Don't forget a negative exponent is a reciprocal. So this would really mean 1 over x to the 8th power. So my final result, I would probably write it like this. Okay, here's our final example to review the exponent properties. And we want to simplify this expression. And so notice that our base thing in parentheses is being raised to the third power. And so all of this being in parentheses, that means that whole thing is your base. But you can also think of sort of order of operations, and you could ask, can I simplify inside there at all? And that would be one way to approach simplifying this expression. So the coefficients, -4 in the numerator and 16 in the denominator, the plain old numbers, coefficients, are really just a fraction, right? So you want to think of, I can reduce that fraction, possibly, or see if you can reduce. So in this case we can, since -4 and 16 have a common factor, we could divide both numerator and denominator by 4. And so I would have -1 in my numerator and a 4 in my denominator, and that would be just reducing those coefficients, the fraction there. But now the rest of this, the powers of x, I have x to the 4th power, and I'm dividing by x to the -1. Well, we could clean that up because that's a division problem where we have the same base, and so I can apply the quotient rule to that, which says I need to subtract my exponents. So I'm going to keep my base of x, but my new exponent is going to be numerator exponent minus the denominator exponent. So you have to be a little careful there because you have to subtract the exponent, even if it's negative. So you really end up subtracting a negative number or adding. So cleaning up inside the parentheses, I could write that as -1/4 x to the 5th power, and that all has to be cubed still. So that was just simplifying inside the parentheses so far. Okay, so now I'm going to think of this as a product, -1/4 times x to the 5th, and it's being raised to the 3rd power. So that means I have to apply that exponent to each factor in the base. So I'm going to take my coefficient, my fraction, -1/4, and it has to be raised to the 3rd power, and then x to the 5th has to be raised to the 3rd power. And so now, -1/4 to the 3rd, well, we have to think of that as the quotient rule. Our base is a quotient, and so -1 to the 3rd, -1 times -1 times -1 is still going to be -1, but also the denominator, 4 to the 3rd. So 4 times 4 is 16, times 4 is 64. And then for x to the 5th raised to the 3rd power, that's the power rule, and so we keep the base of x and multiply those exponents. And so I could have -1/64 as the coefficient times x to the 15th. And that would be one way to write this. But you might also sometimes see this written, though, as one big fraction. So you can think of the x to the 15th is really in the numerator. So if I multiply -1 times x to the 15th, that could just be written as the opposite of x to the 15th. And then we could put it all over 64. So these are just two different ways to sort of write the same expression. So that concludes our review of the rules of exponents. And I just wanted to point out that as you go further in math classes, you'll find that these rules actually apply no matter what your exponents are. For example, the exponents could be fractions, and all of these properties and rules still apply.